In the previous video, we actually derived the understanding of s plus t is equals to 1 with regards to a certain differentiation method and things like that. So in this video, we'll talk about another approach that is somewhat similar to that, but yields us a different understanding and a perspective to a different stuff. So therefore, let's start. So in order to talk about it, we have a certain changes in S, alright, a new changes of the plant. So it's not in terms of the P naught anymore, although there is changes of the P naught, but it's not very apparent over here. And if you remember, we have a certain L naught over here, and as the plant changes, you'll move, the Nyquist spark will actually move to L, right? This is -1. So we're just taking S, alright, just its sensitivity function of this L function minus S naught, alright, that belongs to the system. And so we are just taking the difference between the sensitivity functions, and we see how they actually change, alright. And we'll do that, alright. So S minus S naught over S naught, I'll just simply sub in the S's over here, alright, just simply replacing, and then I'll just divide this thing. So I'll just apply this equation to here. What I have is this one, alright, and this one divided by this one is simply 1, right? This is 1, because this divided by, this divided by this is equals to 1, right? Because they have the same stuff. But I'll just rewrite 1 as in terms of 1 plus Cp naught over Cp naught. That's all. Okay, sorry, I didn't. Yeah, but anyway, so I'll just rewriting this denominator over here. Alright, sorry, my fault. Should be 1 plus Cp over 1 plus Cp, because we're gonna do addition and subtraction, right, or fraction. So we're gonna base on this 1 plus Cp, because in other words, this one divided by this one is equals to 1. Alright, so 1 can be re-represented by any other forms. So it can be represented in terms of this form, 1 plus Cp over 1 plus Cp. Alright, because this denominator is the one that is guiding us to rearrange things in such a manner. Hope you understand. Alright, then this 1 and minus 1, because 1 minus 1 is cancelled out, so I have Cp naught minus Cp over here divided by 1 plus Cp. And we know that Cp naught or Cp are all just a gain, or a loop gain, you would say. So L naught minus, so we can rewrite this as this one over here. And what is this meaning is that it's just the distance between L and L naught with regards to L itself. Alright, so it's just a ratio between their differences with regards to how it's changed across the L itself. In other words, it's a measurement of how L naught minus L, so it's a measurement of their differences with regards to the loop gain L. That's all. Alright? Or to a true meaning is that how much distance is L with regards to L naught. Alright, how much distance is L with regards to L naught. That's all. Alright, if it's larger, then you have a larger number over here, because L naught minus L will be a big number. So it's just a representation of their relation. Okay, now if it's a change of t, in this case, if it's a change of t, just a change of small t, with regards to its original t naught, alright, just simply sub in these equations, and then I'll just divide them. Alright, so when I divide, be careful of, it's just simply math. Alright, just look it out and check it out. Alright, and the same thing that this dude over here and this dude over here will divide each other in and becomes equals to 1. And this is the one that I'm talking about. And Cp over 1 plus Cp divided by this one is this one. And because of the denominator, alright, I can simply write 1 as 1 plus Cp naught divided by 1 plus Cp naught. For some reason, I'm luckily that I've made this careless mistake that I can actually derive this one. The reason is, actually, if you were to follow the denominator, 1 plus Cp over 1 plus 1 plus Cp times Cp naught, if you were to just, instead of writing 1 as this one, you can actually write the 1 as this one. Okay, if you were to write that, then the outcome is a little bit weird, right? But if you were to write in terms of this, and then I multiply in terms of CP0, so I'll just simply multiply them by CP. I mean in terms of CP. Okay, wait this is the better case, alright? This is the initial case that I've just started off. So in terms of 1 plus CP over 1 plus CP. And then I multiply them by CP0. Alright, so that the denominator are the same. From there, then I can rearrange and stuff. Then I can get L minus L0. Alright, so be very careful at this step, but I don't know, if it's needed, then this is a good understanding that I could just convey. And up to this point, you may feel stuck, but you just simply factorize out this 1 plus CP0 and 1 plus CP0. Okay, so what you have, we'll have 1 plus CP0 times CP minus CP0. And then they cancel each other, and there we have L minus L0. And this relationship is a measurement between these two curves. And that's all. Alright? How is this information useful? It's because if only you are given S and S0, or T or T0, and you're asked to find these distances, which is kind of tough, right? It will be more difficult if we were to do that. But anyway, there will be a times where you're gonna apply this thing. Alright, there will be a time where you're gonna apply, because it's in terms of proving that this thing is equals to this one. Alright, it's how the sensitivity difference affects your loop gain changes, some sort of the meaning. Alright, so if you were to ask to actually get an understanding of how the sensitivity function relates to its loop gain, which is L, then you can actually use this form. Or otherwise, if you are to ask to do the relationship between the complementary sensitivity function with regards to its loop gain, also we can actually derive this thing. Alright, because it's just that derivation. If you are to do for S and T, then we're going to also do for 1 over S and 1 over T. Alright, and this is the actual thing that is in your textbook, alright, in your PDF. I pluck it out from there. Alright, it's over here. Okay, with regards to that, this is why I created this one first, and I see this particular relationship. And so, therefore, we can see from here, this is another view in terms of 1 over S and 1 over L. Or 1 over T, sorry. It's a more apparent proof for the S plus T is equals to 1. Alright, it's more in-depth. Right, previously what we derived for the differentiation is to prove that this equation end up will become minus T0. Alright, this is something like that. But in terms of using 1 over S and 1 over T, what you have is something more. Alright, what you have is something that deals with the inverse Nyquist plot. Alright, where your T0 is gonna multiply with the loop gain. Alright, the difference of the loop gain. So it's just that. So this is 1 over L, this is 1 over L0. So it's just the difference again. Alright, but in terms of multiplying with T0. So these are the derivations. I'll not derive it, but this is just an explanation of how things are related, and therefore S0 is also so-called derived after you have a small changes in the 1 over T domain. So this is just some understandings you may need to know. In fact, my thought is that this one should be 1 plus L. Okay, because it's 1 plus CP, so it's 1 plus L. Right. So this is somewhat very similar to the Doyle's stability system. Alright, the Doyle stability criterion. Somewhat of the meaning, but they're all so related that I can't actually see what's the true meaning behind it, but yeah. Therefore, see you in the next video.